we can look at this question. There was a question in the Ask Instructor part of Blackboard, but I noticed that the person who asked the question has since answered it correctly. But I've already want to talk about this one now, so there's just a lot of good things about it. We could get Excel to answer this instantly for us, but I don't want to do that. We want to do this by hand and really talk about the procedure, and then we can check our answer with Excel or whatever. So here's the GPA of the 12 randomly selected college students, and they tell us to assume the population is normally distributed. So sample size is 12, but they tell us normal distribution. Assume normal. So I want to direct your attention to this icon here. If you click that, it will open up the clipboard for you. And the good thing about opening up the clipboard is you can paste it to Excel really fast and then not have to retype all that data. And then you can perform your calculations. I've already put the data over here. And so here's our GPAs. To find the mean, you can let Excel do that for you. I'm going to do it again. You can say this is going to be equal to, like just put equal to into the formula bar here. And you could just say, I want this to be equal to the average. And Excel will just give you the average. And it's about 2.37 because we're rounding. And I wanted to just put that in there real fast, just because of the YouTube has restrictions. So here's the 2.37. It says rounded to decimal places. Sometimes that matters. Here's a general rule. If it says rounded 2 places as needed, then as you go forward, use the rounded data. Normally it's better to round at the end, like it's better to use unrounded data. Just for fun, I'm going to consider both possibilities, like if you're using the rounded and the unrounded. Alright, I went ahead and added some stuff. I just want to talk about what's going on with this question and how to answer it. And it just took too long recording. It displaced for me to be typing and selecting and all that. So I want to tell you what I've cooked up here. So here is our data that we copied from the clipboard in the GPA column. And then we calculated the mean using Excel. We rounded it 2 decimal places for the purposes of entering into MyStatLab. So we take the mean, we take the GPA, like this person has a 2.3 right here. That person has a 2.3 GPA. We subtract the mean in the next column, and you see the difference. The difference, this person is a little bit lower, about 0.07-ish lower. And then we square the difference, and let's talk about why. Look at what happens. Like let's check out the average. The average square difference. Not square difference, the average difference from the mean. Yeah, let me delete that cell. Shift them up. Okay, so the average difference, we're going to take, this is going to be equal to, it's going to be the average of the differences. And this value is going to be very close to 0 only because of rounding. It should be 0, but you see this e to the negative 0.07. That's a very small number. In scientific notation, it'd be, where'd that number go? Oh yeah, in scientific notation it's negative, so it'd be negative 0, 0, 0, 0. There'd be 6 of those, because and then it gets to the 3, 3. It's a very small number, but it's only because of round off. The average difference is 0 because they cancel each other out. Like the higher GPAs cancel out the lowers. So in order to talk about how to meaningfully talk about how spread out the data is, that's why we have this next column. That's why we square the difference. I'll show you. You can do it in Excel. Like you can take the value, the difference, like this difference, and then square it, like raise it to the second power, and then you can do that for all of them. Yeah, I like Excel because of stuff like that. And then this value in the cell right here, this brown couple cells, the sum, all that is the sum of all of these. I just let Excel do it for me. And then because we want the sample, instead of just dividing by the sample size 12, and then taking square root to get the population standard deviation, it's a sample. So the procedure says we take that sum and we divide by 11. So that's what's going on here, right? Divided by 11. So then we take the square root of that to get the sample standard deviation. Remember, for sample data, use S it's the sum of the square differences. That's what we did. Right? We did with the columns. That's what this Greek letter sigma, it says we're summing. We took each GPA, we subtracted the mean in the column, and then because their average would cancel out, we squared their differences. So then the positives and negatives still cancel each other out because you square a positive, the result is positive. You square a negative, the result is positive. That's why we do it. And then because we're dealing with sample data, instead of dividing by n to get the average squared difference, which would be the variance for the population, we divide by n minus 1 to get the variance for the sample. And then we can take the square root of that to get the sample standard deviation. And I know that's a lot, but long story short, we just divide by n minus 1 because we're dealing with sample data. Alright, so the sample standard deviation, we divide it by 11, n minus 1, and then we got 1.12 because we're rounding it. Okay. This third part about the confidence interval, this is going to have to take another video, but I want to just soften up just a little bit about it. They say they want a 99 confidence interval for the population mean. So let's take just one brief look here. What we're doing for 99% confidence interval is this distribution is the t-distribution. It's a small sample size. N is 12. They told us to assume normal. And if the population standard deviation is known, then we can use the normal distribution. But we don't have that. We're using the sample standard deviation. So because we're using S, we have the sample standard deviation S, so we use the t-distribution. Okay, I want to go to the page here. So for the confidence interval, the idea is we want to know how many standard deviations we're going to allow. So if the distribution, they're all kind of bell-shaped, all the t's are, just like the normal distribution. You know, as the sample size gets larger, it gets so close to the normal distribution that at 30 you might as well use the normal distribution. But it's less spread out. The higher the sample size in this family of curves. You have to deal with the degree freedoms. Here, the sample size is 12, so n is 12, so the degrees of freedom is going to be 1 less than or 11. But let's talk about the 99% confidence interval in this last minute here, and then I'll use another video to finish it up. So 99% confidence interval means that we want to be sure that we catch about 99% with that notion of the sampling distribution. So there's only going to be a little bit on the edges here. Like here is going to be 99%. You know, like we are the 99%. You know, like no, I'm just joking. And then here over there, let me use a different color for this is going to be 0.5%. So the area is going to be 0.005, right? 0.5%, yeah. And then this one is going to be 0.005, also the area. All right, I'm getting close to 10 minutes, and I know how YouTube is, so we're going to pick this up in a minute. I'll probably have the other video like finished and rendered and uploaded and all that by tomorrow also. We'll finish this one and look at number 9.